This video is going to cover schematic setup. So we will start with a new project, and there are multiple ways to add a schematic. The first one is on the main menu, Project, Add Schematic, New Schematic. You can see there's a toolbar button as well, which is right above my mouse, and also a hotkey. So that's one option. Second option is on the project tab, right click on circuit schematics, new schematic. And again, you can see the toolbar button. And since that's a single click, that is my primary method for adding a schematic. And that's what I'm going to do. Click on the button. You have an opportunity to name it, but don't panic about this. When you change the name, it is synchronized, and anything that points to the schematic, like graphs or using the schematic as a subcircuit in another schematic, all of those things will be updated by default. So changing a schematic name is not much of a big deal. I'm going to call my schematic pad 3DB. And that's what we are going to work with. Create. So here's my schematic, and you can see it's added under the circuit schematics item on the project panel. So we have our schematic. We're now ready to add elements. Now, a simple 3D pad is simply 3 different resistors. And the way we add them, we go to the Elements tab, Lumped Element, and that's where resistors, capacitors, and inductors all exist. We want resistor, and the basic resistor is RES. And you can see in the upper panel on Elements, this is organization. There's no element that you can actually place in the upper half. All the elements are in the lower half, but you have to navigate in the upper half to find what you're looking for. In the lower portion, you can see there's a model name and a description. And even if the description goes beyond the edge of the panel, just put your mouse over it and it will fully appear. So you don't have to make this panel super wide to include everything. To place a resistor, you click and hold on the name. So my left mouse button is now down. I'm dragging it into the schematic. And when I let go of the left button, I have several options. I can move it. If I right click, I can rotate 90 degrees per click. And if I shift right click, it's going to flip vertically. You can see the parameter box flipping from the top to the bottom. If I control right click, you can see the diagonal line on the left pin of the resistor. And when I control right click, you can see that diagonal line flipping from the left to the right, right to the left. So all those options are available when you place an element. I'm going to place up in the middle, and here is my first resistor. Now, I could go back and drag another resistor, but it would be easier just to copy what I have. So I click on it to make sure it's selected. You can see the dots, not selected, selected. And then there are built-in Windows commands. If I want to copy and paste this, I could go to toolbar buttons, copy, paste, under the edit menu, cut, copy, paste. But you can see the built-in hotkeys, and they are the same as standard Windows. Cut is Control X, copy is Control C, paste is Control V. So that is what I typically use. Control C to copy, Control V to paste. And now I'm going to use the 90-degree rotation to put this resistor right here. Now, you can see that every element has X's at the ends. If you stack them and click to locate the second resistor, the green square means they are connected. And if I move this resistor, just click and drag, you can see it's connected by the red wire. No matter where you move it, it will stay connected. And if I put it back here, the wire disappears, but the green square is still there. They're still connected. If you want to disconnect something, you can hold the control key and drag it. And then if you want to wire things further apart, then just move your mouse over the X. It changes to a wire coil. Click once, click a second time, and there's your wire. Again, you can move it. So I'm going to copy this second resistor. I'm going to flip this one left to right. That's Control right click. And we want to ground the two shunt resistors. That's up on the toolbar. Ground. Or Control G. So two options for placing a ground. And finally, to finish this schematic, we're going to put ports on the two ends of the series resistor. So the ports are up here on the toolbar. Port, one on the left. And again, Control P is this other option for a port. And here again, I'm going to Control right click to flip it and attach it at the other side. Now, if I want to make things a little bigger, the Home key on the keyboard zooms the schematic as large as possible for the window you're working in. And now we've got to set our values. And the rough values are the series resistor is it's in the low teens, but we're going to start at 10 ohms. And these two are the same. So there are several options here. I could double click on the resistor, edit, then double click on this one and edit. I could also click on one, then hold the Shift key, click on the other. They're both selected. Double click on either one, and I could edit it again. But I don't want to have to change both because by definition, they're the same value. So what I'm going to do, they are both selected, double click on either one, and I'm going to change this value to a variable. And I will call it RSH for shunt. Say OK. And now I will add the definition for RSH. And we do that by draw, add equation, and again, a toolbar button, X equals Y over EQN. It's right here. Or Control E to add an equation. I'll just click on the menu. This is where you're going to place it. And I will say R underscore SH equals, and we're going to say 200. And again, that will be adjusted. Now, anytime you deal with variables, it has to be perfectly duplicated. So the case is critical. The underscore has to be there. If this was a lowercase r, you can see these immediately change to red. saying that uppercase R SH doesn't exist. So have to be careful about your case. Okay, now to finish this off and go through tuning these values, I'm going to quickly set up a graph, and that's add new graph. Rectangular. I'll call this S parameters. And now I want to fill my gray workspace with these two windows. So I'll click on the one I want on the left, and then window tile vertical. And here is my schematic and the graph. Again, in the schematic, if I hit the home key, it zooms to fit everything. The frequency is not critical because resistors are not frequency dependent. That means that the graphs here are going to be perfectly flat. And to add the graphs, I right-click anywhere on the graph, add new measurement. You can see the toolbar button to add new measurement. And the default measurement is S parameters. Port parameters, S. Pad 3 dB is my schematic. I want S11 magnitude dB, add, and 2.1, add. Close. And to run the simulation, we click on the lightning bolt. And here are the results. If I just click and hold the mouse on either trace, you can see S21 magenta is about 2.96 dB, and the match isn't bad, 19 dB, S11, but we can do better. And the easiest way to do that would be to right-click, add a marker, and we can put one on each graph, add marker. And now I'm going to set these parameters to be tunable. And the way to do that is double click on the element, click the tune box, and I will also click the constraint. I know that 10 is too low, so I'll make that the lowest limit. And I'm using the arrows to move from box to box, left, right, left arrow, right arrow. When I'm done, I say OK. Notice that R equals 10 turned blue. That indicates that it's tunable. Now, these resistors, you can't tune on the resistors because they have a variable value, but you can tune the variable. So right-click on that equation, properties, tune, constrain, just like we did before. Again, 200 is the lowest limit. And in this dialog, tab will go to the next box, 250 and 1. Say OK, and you can see that this is also now blue. So if I open the tuning window, it's this slider. And by the way, let me go back to properties, untuned. You can use this screwdriver to select. Notice that when I move over the variable or an element value, it changes from dim to a dark plus sign. If I click on it, it is now tunable, but I have to come back in to set the constraint values. Okay, and we open the tuner slides with this tune toolbar button. It's a slider, and here are the two values. So for the series resistor, I want this to be 3 dB, and there it is. But I also want my match to get better, and that's going to affect my S2 one as well. So now we're better than 20 dB. I'm going to take it down to about 240. And then we'll readjust the series resistor. And notice that as that gets better, so does our match. And so here, these values, 14 for the series resistor, 240 for the shunt resistors, and we have exactly 3 dB and better than 25 dB match. So this is the basic setup for a schematic with elements, ports, and variables. And both the variable and element parameters can be tuned. For more tutorials, visit us at resources.ema-eda.com, and don't forget to like and subscribe to our YouTube channel.